Hi everyone, welcome back. My name is Bapi Hamed and I'm your host. So guys, in this video we'll be continuing with our runtime complexities. So guys, as of now we have seen different runtimes inside BigO. So in this video I'm going to discuss about like logarithmic runtime complexities. So we usually define this logarithmic runtime complexities with the help of BigO of logN. So guys, let's take an example and try to understand like what is this logarithmic runtime complexity. So guys, as you can see, we have different runtime complexities. Okay, we have already seen constant, linear, quadratic, and we'll be discussing about this logarithmic one. Okay, and if you see the sample of this logarithmic runtime complexities, so this is nothing but find an element in sorted array. So let's take an example and try to understand what I'm trying to say. So what I will do, I will open up my board, and here I'm going to take one array here. So let's take on one array. So in Python, you call it as list also. It's completely fine. Okay, so let's say I have 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so let's say these are the value I'm having. Now, if I tell you, just try to figure out like 1 from this particular array. Okay, so here if you see 1 is located at the first index of this array, so I can easily get it. But if I don't know the location, okay, if I don't know the location, so what I need to do? Okay, so there is an approach actually we can follow. Okay, we call it as divide and conquer technique. So in this case, actually what we need to do, so first of all, we'll be dividing this array into two parts. Okay, so we'll be taking half of this array. So in this case, actually, if you see, I have 8 values. So what I can do, I can divide this array into section. So let's say this is one section. This is another section. Okay. Let me just draw it. So let's say this is one section. This is another section. So in this case, actually, I'm having 1 to 4. So 1, 2, 3, 4. And here I have 5 to 8. So 5, 6, 7, 8. Okay. So here if you see, I don't need this part. Okay, I don't need this part actually to figure out 1, because I can see 1 is present in this particular array. So what I will do, I can remove this particular, okay, I can remove this particular part, okay, of this array. Now I'll be only using this particular portion. Okay, now here what I need to again do, I again need to divide this particular array into two sections. So again I can divide. So half I can take. So in this case, actually, sorry, I'll be taking 1, 2 and 3, 4. So 1, 2 and 3, 4. Okay, so in this case, if you see, I don't need this particular section because 1 is present here. Now what I can do, actually, I can again divide this particular array into two parts, 1 and 2. Okay, so in this case, actually, I don't need this part. I'll be using this part. Okay, and finally I got my 1. Okay, as you can see, I got my 1. Okay, so this is the answer I was looking for. Now here if you see how many steps I have done here. So here I have done 1, 2 and 3. Okay, so these 3 particular steps I have done to figure out this particular one from this particular array. Okay, so here in this case I can define one equation here. So remember, we have 8 values in this particular array. So I can write like that. So let me just write it here. So I can write like that. I'll be writing 2 to the power 3 is equal to 8. Okay, so if you just multiply 2 3 times, you will be getting 8. Now here if you see, I'm just dividing this particular array into two sections. That's why I've taken 2. And here I have done 3 steps. Okay, as you can see, 3 steps to figure out this particular one. That's why I've written 3. And if you just calculate this value, you will be getting 8. Okay, and I have 8 element present in this particular array. So here actually this is the equation actually I can draw, okay, from this particular array. Now let's see if I want to express this particular thing in logarithmic equation. So what I can write log 2 to the power 8 equal to 3. So guys, if you're not a mathematics person, no need to worry about. So what you can do, actually, you can revise this log concept, okay, like how we can define this log equation and all. Maybe you'll get the idea, and no need to worry about, no need to actually understand this part. I'll just give a brief like idea, like what actually we're trying to find here. So here if you see, we can define this equation like that, log 2 to the power 8 is equal to 3. Okay, so here actually we're trying to figure out the power, okay, power of this 2, which would be equal to 8. Okay, so what would be the like 2 power, okay, which would be equal to 8. So in this case, actually, we already got to know. So here actually the power would be 3. Okay, so if I got this 3 powers, it would be equal to 8. Okay, so that is why actually we're defining log of, okay, log of 2 to the power 8 is equal to which number. Okay, which number would be, okay, to represent this thing as a 8. Okay, so here in this case we saw that log of 2 to the power 8 would be 3. Okay, so 3. So basically here 3 steps actually we are performing to like match with this particular number, okay, which is nothing but 8. Or you can also consider the number of steps to find this particular one, which is nothing but 3. Okay, in this case. Now guys, if I show you my card example, as you can see, let's say we have deck of card here, and if I tell you just try to figure out this 10 heart, okay, from this particular deck of card. So what you will do actually, will first of all divide this part. Okay, as you can see here I have heart, okay, heart symbol cards. Now in this heart symbol cards actually we'll be looking for this particular 10 card. Okay, as you can see this 10 part is there. Again you can divide this section like in this side actually you don't have 10, and if you see this side actually you have 10 here. Okay, so easily we'll get it. So guys, here what you are trying to do actually, one bigger problem statement you are just trying to break down, okay, and you are trying to figure out the solution. Okay, and we call it as divide and conquer technique. Okay, and the runtime actually we are getting from this technique actually, which is nothing but like you can say logarithmic runtime, and we can define as BigO of logN. Okay, so this is what actually we call it as logarithmic runtime. Okay, and if you want to see the graph actually of this logarithmic runtime, as you can see this is the logarithmic runtime actually graph. So here actually what I have done actually, I have plotted all the actually you can say runtime complexity graph. As you can see we have seen like constant one, we have seen also, then we have also seen like the linear one, and this is our you can say quadratic one. This is like very worst case scenario, as you can see here, and this is the logN. Okay, so this is the logarithmic one. So basically we'll be considering this like 3 runtime complexities, okay, in our code, and if you are getting these kinds of runtime complexities in our code, okay, so we'll be avoiding this part. Okay, so yes guys, this is all about our runtime complexities. Okay, different runtime complexities. I hope you got the idea. So guys, in our next video we'll be discussing about something called space complexities. With that actually, thank you so much guys for watching this video, and I will see you next time.